How to do question number 22. First, you need to understand the question. So questions given 1.55 gram of iron ore. So 1.55 gram of iron ore. So iron ore basically consists of iron and also other impurities. And then when this iron ore dissolves in acid, all the iron inside the iron ore is being converted to Fe2+. So it means that when it dissolves in acid, all converted to iron 2+ ion. And this iron 2+ ion is titrated with KMnO4. So I exclude potassium ion here because basically the potassium ion is the spectator ion, won't involve in the reaction. So only the permanganate ion will react with iron 2+ ion. And then the question says this Fe2+ when react with permanganate ion, Fe2+ will be converted to iron 3+, while MnO4 permanganate ion, it will be reduced to Mn2+ ion. Okay, and in the first part of the question asks us to balance this redox equation. Again, to balance the redox equation, first we need to split the species into their respective pair. So iron 2+ and iron 3+, they are one pair, and permanganate ion and manganese 2+ ion is another pair because they are having same species. Iron 2+ and iron 3+, so same iron species. Okay, and permanganate ion and manganese 2+ ion both having manganese. So step number 1, we separate them according to their respective pair. And then we balance the atom. To balance the atom, first we need to balance the atom beside oxygen and hydrogen first. So for iron 2+ ion, so 1 iron, and on the product side also 1 iron. So means that the atom is balanced. How about the charge? On the reactant side, the total charge is +2 because 1 multiplied by 2+. Okay, so the total charge on the reactant side is +2, and on the product side is 1 multiplied by 3+, so that is +3. And the difference in the charge between reactant and the product side is 1. So the difference between +2 and +3 is 1. So therefore, 1 electron is needed, and that electron must go to the side which is more positive. And we can see that product, by having the total charge of +3, is more positive. Therefore, this 1 electron is added to the product side. We do the same thing for the another pair. So we balance the atom first. So other than oxygen and hydrogen, there is manganese. So 1 on the reactant side, 1 on the product side. So manganese atom is balanced on reactant and the product side. So then we move on to balance oxygen. To balance oxygen, we need to use water. So here 4 oxygen, therefore we need 4 water to balance the oxygen. After to balance the oxygen, we need to balance the hydrogen. So we have 8 hydrogen on the product side. To balance hydrogen, we need to use hydrogen ion. So there are 8 hydrogen on the product side, therefore 8 hydrogen ion. So now the total charge on the reactant side is 8 multiplied by +1, so +8, and this is 1 multiplied by -1, -1. So the total charge on the reactant side is +7, while on the product side is 1 multiplied by +2, 4 multiplied by 0, 0. So the total charge on the product side is +2. And the difference between the charge on the reactant and the product side is 5. Therefore, we need to add 5 electrons to the side which is more positive. So which is reactant side which is more positive. Therefore, we add 5 electrons to the reactant side. Okay, and then after we have balanced the atom and the charge of the two half equation, then we need to identify which equation is oxidation and which one is reduction. So we know that oxidation is losing electron. So electron will appear on the product side. And we can see that the iron half equation having electron on the product side. Therefore, it is oxidation's half equation. While for the manganese half equation, okay, it is reduction, because reduction is gaining electron, having the electron on the reactant side. So this is reduction's half equation. So how do we get the overall redox equation in acidic medium? So how do I know that this is in acidic medium? Because the question mentioned that dissolve in acid solution and then titrate straight away with permanganate ion. So therefore it is in the acidic medium. So to get the overall redox equation in acidic medium, we need to equate the number of electrons for both half equation. So for reduction, we have 5 electrons, while for the oxidations, we only have 1. So to equate the number of electrons, we need to multiply the half equation of oxidation by 5. So that will give us 5 Fe2 plus, 5 Fe3 plus, and 5 electron. And then we can see that the number of electron on the reactant side is same with the number of electron on the product side. So we can cancel them out, and then whatever remain on the reactant side will be the reactant, 5 Fe2 plus 8 H plus ion plus MnO4 permanganate ion. That will give us whatever left as the product. So that is 5 Fe3 plus 1 Mn2 plus 4 water. So this is overall redox equation in acidic medium. From the question, we can see that in order to react with iron 2 plus ion from the iron, 92.95 ml of 0.02 molar of permanganate ion is required. So in order for us to calculate the percentage of iron in the sample, basically we can find it from the informations that are being given for the permanganate ion. So can you see that we have been given A, we want to look for B. So therefore, to solve this question, it is just the normal 3-step problem solving. So step number 1, we need to find the number of moles of A because informations are being given to A, so which is the permanganate ion. To find the number of mole, we just need to use the formula molarity multiplied by volume of solutions in liter. Since we are being given molarity, which is equal to 0.02 molar, multiplied by volume of solutions in liter, so that will be equal to 0.09295 liter, to give us the number of mole as 1.859 times 10 to the power of negative 3 mole of permanganate ion. And in step number 2, we want to find what is the stoichiometric relationship between the permanganate ion and the Fe2 plus ion. So that is given in the balanced chemical equations that we found in part A. So from the balanced chemical equation, we can see that 1 mole of permanganate ion will react with 5 mole of Fe2 plus ion. So that is the stoichiometric relationship between permanganate ion and iron 2 plus ion. And now we have 1.859 times 10 to the power of negative 3 mole of permanganate ion. So therefore, X mole of Fe2 plus ion will be reacted with. And how to calculate the X? So basically cross multiplying. So 1.859 times 10 to the power of negative 3 mole of permanganate ion multiplied by 5 mole of Fe2 plus ion divide by 1 mole of permanganate ion, and that should give a 9.295 times 10 to the power of negative 3 mole of Fe2 plus ion. And in step number 3, we want to calculate the mass of Fe2 plus ion. Okay, so why we want to calculate the mass of Fe2 plus ion? So basically, the mass of the Fe2 plus ion is representing the mass of the iron inside this iron ore, because only the pure iron in the iron ore will be converted to iron 2 plus ion to react with permanganate ion. Therefore, by calculating the mass of Fe2 plus ion that react with the permanganate ion, we can get the mass of iron that is actually present in this iron ore. So how to calculate the mass of Fe2 plus ion? We use the number of mole that we calculated, multiply by the molar mass of iron 2 plus ion, that is 55.9 gram per mole, and that should give us the mass of Fe2 plus ion as 0.5196 gram. And basically the mass of Fe2 plus ion is equal to the mass of the iron inside the iron ore. So to calculate the percentage of iron in the sample, or to calculate the percentage of purity of iron inside the sample, we can use the mass of the iron in the sample divide by the mass of the iron ore multiply by 100 to give us the percentage of iron in the sample as 33.52%.